is on electronics fundamentals, which is very exciting. Start with Ohm's law, Christie's favorite. It's V equals IR. What this means, the definition down here, the current through a conductor between 2 points is directly proportional to the potential difference, or the voltage, across the 2 points. So voltage is, as it says, another name for potential difference, and it's when you might have a buildup somewhere, and you might have nothing somewhere else, so you have a voltage there. Voltage is measured in volts. Current, I, is measured in amperes. Resistance is measured in ohms. I don't really know what to say. Do you have any questions on Ohm's law? Do you know what it means?
How do I calculate
Resistance? There's this nifty triangle. It's V over I. Power, we can calculate by taking the voltage and multiplying it by the current. It's measured in watts. Electrical power is the rate at which electrical energy is transferred by an electronic circuit. It's a fundamental part of how everything runs. So we have a few different types of signals. We have DC and AC for this example. DC, it all travels in one direction, so it goes from one point to another, and it always goes in that direction, versus AC, which can go from one to the other, and then it switches and goes back and forth and back and forth. Here are some examples. That direct current, the DC, the red line, is just constant. So it's at, what we'll say, plus 3 volts through that whole time, versus the AC, which oscillates back and forth between going one way and then going the other way. Mains is the general purpose AC electrical power supply, aka an outlet. It's where we get power from. In the US, it varies between about 116 volts and 124 volts, and it's around 60 hertz is the frequency of oscillation. There are some bigger ones. I'm sure you've seen the ones that don't look like these. The prongs look different. Those are at 240 volts. So we have a few different types of components that make up electronic circuits. The simplest is a resistor. As the name implies, they resist current flow across or through them, resulting in voltage across its terminals. When we make electrical diagrams, circuit diagrams, this is what a resistor is in it. Here's an example of what one looks like. We can add resistances together. If we have multiple resistances in a row as series, they're just all added together. So if you had 5 ohms and 10 ohms right in a row, you could just have one resistor that was 15 ohms to replace it. Versus parallel, which it drops all the voltage across them, but all equally, and it's given by this, which would be 1 over the equivalent resistor equals 1 over the first resistor plus 1 over the second resistor plus however many you have, 1 over them. Capacitors are another part of circuits. They are passive electronic components consisting of pair of conductors separated by a dielectric. They work by, well, they store energy in an electric field. They block DC, allow AC to pass. Their units are farads. Here's the electronic circuit diagram symbol, and here's what capacitors, an example of a capacitor. We looked at them a while ago on some other boards to see whether capacitors were bulging, and see if they're bulging, it's an indication that they're bad. Inductors is the kind of the a brother of the capacitors, but it stores it in a magnetic field, stores energy in a magnetic field instead of an electric field, and they're measured in units of henries. And here is the circuit diagram representation for an inductor. This is one such example. Transistors might be one of the most important things invented in the 20th century. They are it's a fundamental part of electronics. They are semiconductor devices, and a couple uses are amplification and to switch signals. How I think of it as, here would be the transistor. I think of it as a hose faucet. You can shut it and you can open it, and based on one of the voltages, it controls how much flow you have through it. So I think that's a good example.